Okay, I was just going to deploy my AI service without making a video into my cluster, but I thought, okay, maybe I create a video because then we will put everything that I have taught you so far in this channel in practice. So we are going to work with Helm charts, we are going to containerize this service, we are going to create a CI/CD process for the deployment. I'm going to deploy into Minikube. I need to have it with Minikube. I don't need a complex cluster, but the process for you is going to be the same. Doesn't matter which cluster you are going to deploy. We are going to go through the thinking process, like what do we need, what do I need to configure, how the persistence volumes are working, and things like this. Yeah, so let's just jump into it and see. I'll show you what do I mean. Okay, so I wanted to show you the project, but I mean, I'm gonna show you the project anyways, but I was also thinking that why am I going to do Minikube? Because I already have a cluster and I can add my machine as a GPU node to that cluster. So then this means that I don't need to create any startup services for Minikube to come up when the PC is up, and the Kubernetes cluster will automatically actually take care of the scheduling my services. And when this node is up, I can even have health checks in that machine, and then I can know that this machine is up. Then I can show it on my device that hey, this machine is up, so you can actually do GPU stuff, you can talk to it, and things like that. So we are going to check the service. Right now, what we have is a gRPC service, and it only this part of it is implemented. This method is this procedure is implemented, which is the talking, and it gets a talk request. The talk request is and it contains audio which comes from the microphone. You have probably seen it in previous videos, but I'm going to go through it deeper. Then there is a wake up. This wake up only happens, actually I also have to change this a little bit to make it like one of these. But this wake up happens when the speaker is done playing the audio. Like I have this speaker here, this one, and then I also have a Raspberry Pi 5. I do not have that board anymore. I have Raspberry Pi 5, and then a Go service is running there. And when the playback is done, it is going to send a message that says, "Hey, I'm done talking. You can start listening again." So this is what it does in the talk request, and it streams. So and that I do that because, for example, when the processing starts or the talking starts, it should not listen to anything anymore, because then while it's processing, it buffers the audio from the microphone into the gRPC request, and then when it starts processing again, even if I don't say anything, it gets into a loop of talking, so it hears itself also. That's why I'm separating this right now. Later, I'm probably gonna add some voice recognition. I right now have a voice activity detector, but I probably gonna have like it detects only my voice. But right now it doesn't matter. And then I generate a response. So the response is either it's final, it's like the end of the audio, and the audio itself, or the state. And the state is going to say like it's idle, listening, processing, answering, and so on. And based on each of these, I have a monitor there, and also the speaker itself. For example, on listening, it's going to say yes, like the hum, which Siri does. So this is what happens here right now. So basically, you can get the idea of what's happening here. But if I go to the implementation itself, I know it doesn't really look pretty, but I did my best to do a Python service, a Python gRPC service. I can start from the server. What will happen here is that the request just comes in, then it will go to the, let me see, this is the Tiba service. Then it goes to the Tiba service. The Tiba service will start a stream service, and the stream service will take care of all of these different stuff, right? So it's going to say, I wait for the wake up word. So for example, I changed it. So quick update. My personal assistant name is no longer Jarvis, it is Tiba. And like Tiba is like something, an old name that I always wanted to give to my to a robot that I built myself. But it doesn't matter right now. You say like Tiba, and then it always checks if there is a wake up word, and if it detects a wake up word, it's going to wake up the code, and it's going to say, hey, I'm awake. And then after it is awake, so since it's not false anymore and it is not locked, so the locking happen only when I say, okay, it's speaking right now, then it gets locked. Then it comes here, then it checks, for example, if what's coming after the wake up to the server is a speech or not. So I don't want to just send it to the whisper. I say, okay, is it a speech? And for checking that, I use the WebRTC event. And then it's the same thing that, for example, MS Teams uses, or like, for example, Google Meet uses. That's like the part that you see in the microphone that someone is talking or not. That's the VAD. That's the voice activity detector. Then I say, okay, if after a certain time you didn't get anything new, so that there's no speech, because if there is a speech, I always reset the timer. But when there is no speech, I time out, and then I say, okay, did you find, how many times did you find the speech there? If the speech time is more than 6, which is a threshold, I have to make it probably put it higher, because when you talk, it takes much more than 6. Sometimes it shows you that it had found 300 speeches and so on. So it had triggered 300 times. And then it says, okay, now if you found actually a speech there, then lock, because now you have to start talking. Then now it's time for processing. Now I will just going to send all of this audio that they were just recorded to Whisper. Whisper is going to transcribe it and then sends this transcription to Llama, and Llama is going to generate an answer. The answer gonna go to Piper, and Piper, which is like my TTS service, Piper is going to create an audio and then chunk it and send it back to me. And then I will send all of these chunks, stream all of them into my Raspberry Pi, which is like very quick, and then it's going to start talking. But for example, the chunks is going to be transferred very quick, like it's like, let's say, in less than 50 milliseconds. But then playing them gonna take a while, because then it has to talk. That's why I have the lock, and I also have some state management, that the microphone gets cut out until the speaking is done, and then the microphone gets switched back on again. And then if it has not found any speech, it is just going to say, okay, this is down. So it's like, for example, when you call out Alexa, and then Alexa, so when you call out Alexa, and then Alexa will get blue, and then if you don't talk to it, then it gets off again. So this is kind of the same thing. If it didn't find any speech, it's just going to turn off automatically, and again wait for the wake up word. So this is our service. But before we start with containerizing it, I already have containerized it, but we are going to go through how I have done it. Before that, let's actually jump back to Kubespray and see how we can add this machine, which is like this one exactly, into my existing cluster. Okay, so in order to start, first we need to jump into our installer node, which we had this inside this video. I'm just going to share the link. Actually, that's the machine that we started with the Kubespray series and so on. So I'm just going to simply jump into it. We have to give that machine passwordless access to this new GPU machine that we want to add to our cluster. So in this case, so if I show you right now, if I want to get into this machine, which is this one is the Pop OS machine, is the machine that I'm hosting right now, is the GPU machine. This one wants password. I don't want that, so I'm just going to copy. So if you have an installer node, you probably already have a key, SSH key generated for you, public key generated. So you don't need to do the SSH keygen anymore, and then you can just copy that one. And since I have multiple, I want to just copy the one that I used previously in the previous video, and I want to copy it for this user under this IP. So it's gonna get the password for me. And now if I say SSH, I should have it here, I can just access now without the password. So now I am back into my machine. So as you see, it's basically like I'm here. So I'm back to my machine. And then what I want to do, I'm actually doing it from the installer node. So maybe your machine is not really the machine that you're using right now. That's why I'm doing the whole thing. But I could easily just also do what I want to do right now directly here from the machine itself. But I am right now in the installer node. The installer node had an SSH connection to my machine again. And then from this one, I'm going to change something. So what do I want to change? Since it is my personal machine, I probably gonna remove this later for security reasons, but you can also leave it, or you can also remove it after the installation. So what I want is that I want to go to the sudoers. Actually, I want to nano them. So it's the nano sudoers, and yeah. Here I want to add this line. So this is going to allow me to get into the super user without entering my password. So if I exit from this node and come back to it again and say sudo su, I can just become the sudo user without the password. Now what I need to do is actually pretty simple. What I need to do is I'm going to come to Kubespray. So your installer node probably have a Kubespray folder because we cloned it from GitHub. And you will have the inventory, which you actually installed your cluster from. Let's go to the inventory and let's see what we have here. So what I want is this cluster. These are the sample ones. And also notice that this cluster was installed with a much older version of Kubespray. That's why you will see hosts.yaml. This doesn't exist in the new versions, and you just configure everything from the INI, which is actually pretty simple. And I already have described this inside the video I have up there. Yeah, but I will also link that in the description. That's the offline installation of Kubernetes. So let's see, what do we have now here? So under here we have so we have everything. We have the configuration, and we have to add a new node. I already have 2 nodes, and this new node is gonna call it like node 3. And I'm just going to call it Ansible host. Actually, I think I can become a bit lazy here and copy paste stuff. No, copy pasting is good in this case, not always. So in this case, now we change the IP address. The IP address of my machine is, if I check, is this one. This one is a VPN and so on. So let's now, so now this is there. Now what do I want? So it is a worker node. So for sure it is a worker node. I'm going to add it as a worker node. It's not the etcd host. I don't want the etcd to be running on this machine. And that's all. That's all I need. Now for the installation, what you need, we already have actually done what we need, is that we just added the node 3 into our cluster. We have to run this command now for Ansible. For this version of Ansible, right now it is a little bit changed. I may create a video for that, but right now for this version of Ansible that I have, what I need is that I tell it, okay, you need to go on and install read from the host's YAML. You need to become the user, become the root user. The user that you have to use is Farad Nozari, and you have to use the scale YAML. You should not use the cluster YAML, because the cluster YAML is to install a whole cluster, but the scale YAML is to install everything which is new. So it knows that, for example, when it say, for example, kubectl get nodes, it says, okay, I have 2 nodes, and then in my host YAML I have 3 nodes. Then this means that I have to scale and add a new node. So let's just run this, and yeah, we'll get back after the new node is installed. So basically, if I do kubectl get nodes, right now it's trying to connect to minikube. No, that's actually wrong. Config use context on cluster kubectl get nodes. Right now it has 2 nodes. At the end we want 3 nodes. Oh, there is an error. Let's see what is this error about. The node 3 is okay, the node 1 and node 2 are not reachable, but actually it makes sense because I'm setting the user to this one. I may need to add a new user, or I need to find a way to specify their own users, so it doesn't really go on and use this one. So let's check that and see how can we do that.
3 hours later.
After discussing the issue with ChatGPT, it makes things a lot easier. So let's see if this approach works. I didn't know this. So inside the inventory, home cluster, and here inside the hosts YAML, you can actually set Ansible user. So if I come here and say my Ansible user is KTS admin, for the old nodes it is KTS admin, and this one also Ansible user is KTS admin, but this one is Ansible user is my user. So let's see if this actually will help. If now we run this means we do not need this part anymore, and see. Now I'm actually also not sure if it is really KTS admin or is it just Farhad, because I am connected to node 1 with Farhad, and let's see the other node. Actually, I can do it from here, it's better. Okay, it is not KTS admin. I guess, yeah, okay, I see. The KTS admin has been just for the video. Let's go back to cd inventory home cluster, yeah, nano hosts YAML. So it's not KTS admin, but it is Farhad for both of them. The old ones are Farhad, and my PC is so let's run this again. Does work? Yeah, okay. Currently all nodes are okay. Let's see if anything new comes up. Okay, another error came up, which was not expected. Apparently there is a check for the operating system which is going to install on it, and I'm using Pop OS, which basically is Ubuntu, but it's not recognized. So we probably need to add this somewhere. So let me check where, and then I'm gonna get back to you. Okay, there is a bunch of ways to do this. Again, I like ChatGPT a lot. So to do this, we are going to just go to inventory again, and under home cluster hosts, let's see if it will work. It seems too easy to be true, but let's just give it a try. So apparently you can say Ansible distribution, and for this one you can say Ubuntu, and since it's Pop OS, basically everything is the same. This should be fine. So let's see if it will actually. Okay, so again I am getting the Pop OS issue. I'm probably gonna solve since it didn't really work. Yeah, so one thing is that about the Ansible playbook is that there are these scripts, or like this configuration, which it goes through and then it does whatever the configuration is there. So probably there are certain operating systems listed there, and we have to just go on and add Pop OS there too. So let's see. Let us reinstall browse, and yes, so let's see if it is actually here. Yep, it kind of is, but I don't know if this is the one that we have to change. So it says from the family of Debian and Red Hat, and it is the family of Debian and Red Hat. So let me see if we find Ubuntu somewhere. Okay, I have to go deeper into this. After I find the solution, then I'm just gonna get back.
One eternity later.
Yeah, I think I found where it is. It is under the pre-install, but you have to go under to get out of this remote where I was. Defaults, yeah, under defaults, and I found the supported OS distributions, and yeah, PopOS is not really here. So let's add it and see what will happen. And it is like this. Yeah, so let's actually now run the thing again. I do need to get out. So as you see, it was under Kubespray rules, Kubernetes pre-install defaults. This is in case if you have a PopOS. Should not really happen with other operating systems. They are mostly supported, and PopOS is like kind of gray area. It's not really verified. So let's see. It's always a great pleasure to do something which is not or which is controversial. I am trying to install a node which is running PopOS, which is basically Ubuntu, but probably none of the developers of Kubespray have thought someone may add a PopOS to a cluster. And I'm trying to do that, so it should have the same fix, right? So under the tasks for Containerd, I just need to add PopOS. That's all. So let's add this and see if it works. Yeah, okay. So I'm probably gonna have this for almost every place that it is going to check for the distribution. So as you see, my error was coming from Container Engine. By the way, this was not coming from ChatGPT. ChatGPT actually told me to do a quick and dirty solution, and I do not want to do that. It said just ignore all of these errors, like for example, let it skip, but I don't want to let it skip. Some checks must happen. So again, as you see, I had the error from Container Engine, and then Containerd had the error again under defaults. There's a main YAML, and here I'm just gonna go and say, hey, add pop OS. I just wish the error was exactly the same as the other one, because now this one sounds like Containerd itself is not supporting PopOS. So it's scary, but it's no. So the validation is failed. So yeah, but it does support Containerd should support Ubuntu. There's no difference. It just looks fancier. Not fancier, really. I like Ubuntu more, but doesn't matter. Okay, that was our last change for PopOS. I'm happy. So it ran, and the node 3 is added to my cluster. Let's actually come back here and say kubectl get nodes. Yes, the node is up and running, which is computer. It feels strange that this is the same computer I'm working it, and it is a node. Yeah, so let's just jump into it. And so one thing that I for sure have to do is to tell the control plane node not to schedule anything on this machine, so except the GPU based pods. So right now, if I go to node 3, there's some stuff running here. For example, Ingress is a daemon, that's why it's running here. I have an Nginx privacy node. Don't know what it is. Interesting. Then because I know this one, but this one I don't know. To check. Then I have like everything which is normal here is fine. So yeah, that's something I definitely have to do. I'm gonna do it off the camera, and then we are gonna get back. So what we need to do is to test this. So right now on my machine, on this one, if I do Nvidia SMI, I have I have information from Nvidia. But I'm pretty sure right now if I do it in any of these pods, I cannot do that. So let me go to, no, that doesn't matter. So yeah, probably cannot do that, but we're going to put that to test. Let me go on and then configure all of these pods that I have not to run on this node 3 because they shouldn't. and also label it as the GPU node. So I already have one GPU node, but it is not really a GPU node. This one, the hardware type GPU. I'm going to like call this like hardware type Nvidia or something, and then I'm gonna schedule my new service on this one. Then we are going to figure out how can we make the GPU also work here. Okay, so I found an easier way to stop the pods from being scheduled, because I kind of forgot about taints. I just added the taint to node 3 that says it's dedicated to Nvidia and nothing should be scheduled on it unless I explicitly say so. So now this way only so these are the system pods, and they all have the there's a tolerations set on them, and the toleration just ignores the no schedule taint. So then this way that's how, for example, Calico, Node Local DNS, and Kubespray and so on are running. I still don't know what I have installed this for, and I don't really care, but apparently it is also ignoring the taint. I had an Nginx Ingress controller running here. It's not running here anymore because I really don't want it to run here. And the reason that I don't want them to run here is that, for example, let's say that if some of the pods from my database running here and then I turn off my computer, then I don't have my database anymore, because my habit tracker, which I have the video about it too, is also running there, and it is on 24/7. And like my servers and this computer, I don't want to keep it on because then I have to pay a lot of electricity. No, so yeah. Now we need to make sure that this cluster, like this node, can see my GPU driver. As I showed you before, if I do Nvidia SMI, I can see my driver, so my GPU is running on this machine, but the cluster itself cannot see it. I ran some commands to see if it is there. Apparently, there is a plugin for Nvidia from Nvidia, which is going to make this happen yeah, so your pods can see the driver. So let's just install it with Helm. So I'm just gonna add the repository here, and I'm gonna update my repository, and then we will have Helm upgrade install. But before I do this, we also need to configure the toleration. So we want the toleration to, let's edit it here. We want the toleration to ignore the taint. So in that case, I need to add this to the installation, and I also need to this is fine. I also need to add that's it actually. So let me not save it. Let me go on and then run this. So let's see now. Under the nodes here on the node 3, I should be able at some point see this coming up. Okay, we have a mistake in our installation. It actually should work. Let me add the set after. Okay, now. Okay, for the sake of my sanity, I'm just gonna go to the values YAML and see what's going on here, because one thing I didn't know is that you have to have the GFT on, and it went through all of my nodes that I have, and they also have Nvidia running on them, and then labeled them as such. And because of that, then it starts running them start running the plugin, but the plugin also had an issue to run. I right now I'm not running anything, so I just went here to see what are we dealing with in the configuration. So I'm just simply going to copy this here and see what's going on. Obviously, we do not need all of it. This is the default values. These are the default values anyway. I had also one issue with this repository. I cannot fetch from it. Yeah, that's interesting. But anyways, let's first deal with the tolerations. So here are all of the tolerations that already has some. In my case, there is also the dedicated key, and the operator has to be equal. Value is Nvidia, and effect is no schedule. So this is one place we have to set this, and since the GFD worker is also going to not the GFD but the NFD worker also needs to run on my third node, so I have to also add the same toleration here. So that would be dedicated. I'm doing this, and operator is equal, the rest is okay, and do not really have anything else. So I would say let's just run this and see what will happen. And I will actually going to name everything easier. So if I go back to here, and there's the helm deployment, I forgot how the thing was called. It's this one. We need this one. So I'm basically gonna say kubectl, helm install, and I'm gonna call it Nvidia, and this is the repository it has to install it from. F is Nvidia YAML, N is what do we call the it's here, Nvidia device plugin, Nvidia device plugin. Yep. Okay, so let's see what it did now. I come back to my pods here. So I have the device plugin here running, but again I do not have the it's because I have the GFD disabled. So let's have it also enabled and run this again. If I said it should be enabled, then it's just going to go through the node 3 as well and label it. So then after it is labeled, then the daemon set will run this one also. So let's see, is now enabled. Let's see, node 3. Yep, node 3 is there. So this is node feature discovery, and it's going to now mark my node 3 with new labels. Let's go see. Yep, now they are all there. And if I go back to the pods, I have to see the device plugin here. Yes, it is there, but it should be red. Yeah. But let me see. It is not only this one which is red. Yeah. Oh no, it actually has pulled. Let's see what's wrong. Plugins unable to create plugin. Failed to construct invalid device discovery strategy. This is not a GPU node. You should set up acceleration or node selector to only deploy this plugin on GPU nodes. Yeah, I mean that's true. Those two other nodes are not GPU nodes, but this one is. If this is a GPU node, it should configure the Nvidia Container Toolkit. Yes, I did. Yeah, this is the other thing. You have to install the Nvidia Container Toolkit. Just say search just this Nvidia Container Toolkit and just need to install it. There's apt install, and then you will have it on your machine, and then you have to restart containerd so it works. Yeah, but let me figure this out again, and I'll just go through this to see why it's not running, and then I will get back to you. Okay, I realized the version I had was an older version for the Nvidia Container Toolkit, so it was not recognizing containerd as a valid runtime, and it was connected with Docker. So I am going to just run these to see. I just removed the old one, and I'm going to see if we can get the latest version. Configure the repository for the packages. No, update the package. So let's do this. Okay, and now if I run Nvidia, it should be there, yes. And the version is, yeah, that's good. I had version 12, which was a bit older. And let me see, yeah, we have to now restart the container D. Does it have the container D configuring for container D? Yep, so we have to set the runtime to container D using version. It is recommended container demo be restarted. Yep, on it. Let's do that. Let's restart container D is installed. It is restarted, and yep. So now let's go here and see what's up. Again, that into an error. It probably can be something else. Okay, just for your information, right now it is running. This means that I was missing Nvidia set as default inside the toolkit configuration. The container toolkit configuration is not really documented here. Again, lack of documentation. Yeah, so as soon as I did set it as default, now when I run this command, then I get both of them are available, both of the tags are available. So yep, let's go on and create a Helm chart for our LLM service eventually. One thing which is important about that LLM service is that this machine has to be the machine which is going to have the persistent volume paths in it, because it's going to run here, and I already have the old llama the models run saved on this machine, and also have all of these speech models, like for the text to speech models here. So I'm just going to load them from here to the container. Yep, let's go on and create the Helm chart. Okay, so let's create the chart. Actually, creating this chart is pretty straightforward. The only value I have right now is image registry. Of course, if you're creating it in your own company, go on and add more stuff. For me right now, this like only having the registry here is enough. And I'm here. If you have the Helm extension installed on VS Code, you're going to get suggestion. You can just have IntelliSense for Helm, and then yeah, so adjust it based on your need. And for me, this one is going to be called Tiba LLM. Let's say the port, I guess, is 50,051. If I'm not mistaken, let's just double check quickly. And come here, go to Tiba. Yeah, this one also right now really doesn't have a, yeah, that's correct. Doesn't have an environment variable either. Yeah, so really don't need it right now. The replicas by default is going to be 1. I'm just gonna remove it. The chart name, I'm just gonna call this one main, and yeah, so we also need to handle the image. So the image is going to be yes, printf gonna be s is my registry, and then comes the repository, which is the, let me find it. Actually this part is my repository, and then comes the image tag. I'm just gonna call this I don't know, let's see. Actually, this is the chart. I have to come back into Tiba and then go to itself, this one, and there's no GitLab CI yet. So when I push it, I can just push it as main, and then it's going to be main 100. I would put it like this, and then I save like version and the version is this one, for example, I would like to add a V. When I do the deployment, I'll add the V, and then this one I have the values for image registry, and then comes here the version. So there I have the image here. So I'm just gonna come and add the image here. The rest seems to be fine. I don't need these parts for now, at least. Here comes the port, and the environment variables I do not have, but I have the image pool secrets. So let's go on. I already have the, oh yeah, that we also have to add. So let me actually then add this under globals, because yeah, this is under global. I don't know why I named it before like that, but doesn't matter. Then comes the image pool secrets. Yeah, so it's an array, and it has name and then the value. So let me go on and then just steal it from my own code, because we need to do this include here. So yeah, this include will basically yeah, get the image pool secrets from here, and then add it into my template. One other thing that I still need to add here, let me format it a little bit, and this is now under global. Image registry. Let me registry together. Yeah, so one thing that I'm forgetting to add is the tolerations. So I need to add the tolerations here. That should be fine. My toleration was, I guess, dedicated, and then the operator is equal, and then Nvidia, and then the effect is no schedule. So this actually should deploy this. I'm going to also add my service here as well, because yeah, I already have this, so why not? The type by default is cluster type, and I don't need anything else. Even if I remove this, it's going to select the cluster IP anyway. Let me do a little bit of formatting here and say this is the port. Target port is also this one, and the name, and that this one is not really needed. It's going to be set to that by default. And yeah, that's it. Let's push this and then go on and then configure our Flux. Let me initiate it. Okay, so now it's time to install the chart that we just created. The image is not also published yet, but it doesn't matter. We are going to first run the deployment and then see like if the tolerations and everything is going to work, and then we are going to take care of everything else. So here I am in my Flux, which we checked in the other video for Flux, and I have already a release and repository and so on. Here I'm going to separate this to smart home. So this is a smart home for Tiba, so I'm just going to put this there. And then I also going to have the Tiba itself, like just LLM call it. And I'm going to need exactly same things there, except that here I'm gonna need Tiba chart, which was what we called it. And we have to also change this name. We need a new authentication token here, because this one was for the smart home repository, And for the release, we do not have really any values, and the rest is fine, except that we need to change some names. So this is Tiba LLM. The rest seems fine. I'm just going to reduce this. And this one is also Tiba LLM, and I'm going to also use this as well. And it's going to read the Tiba LLM repository. That's it. So now let me go back to GitLab and go into the new project that we just had, Tiba chart. Okay, so now here again, as the same as I described inside the Flux, inside the Flux video, we need to come here and create a deployment token. I'm gonna skip this and then just show you that I created the token, because I have no plan to remove this one. I need to keep it. Okay, I just created the secret to let Flux access my repository, and I'm going to need to set this, well, here. Now I guess everything here is also ready. One last check that I would like to do is inside the chart which you just created, do a lint to see if you have any issues. Not really any issues. And that'll be actually one thing, one thing we need to do, that would be to set these ones. So yeah, so this, let me move this there to the release, and then we have the values here under the chart, and just like that. Nope. So I need this. I do not have this, and this one I also don't need to set, but it is okay. See this again. Everything seems to be fine. Let's just say Tiba LLM added. Okay. We should not really expect that it starts running after it's deployed, because there are a lot of stuff missing. But we at least need to see it gets scheduled. So let's see. Yeah, right now it is complaining about the versions. It doesn't match up, but that's not an issue. You can also use the Flux CLI to do the compiling. So let me do that. Compile, and then you say what do you want to reconcile, and I say okay, I want to do a git repository, so that's under the source, and then you say what is under the source, say git, and then you give it the name. So I want to reconcile this Flux system under Flux system. So let's do this one. Okay, and then I want to do it also for the home. This is a smart home under the home namespace. And then now let's do the helm release. So that would be the helm release, and the name is smart home under home. So it's Tiba home not found. Okay, that's because the release is this one. The release is using wrong name. First name fixed. Is this created? Oh, yeah, great. Now it is there. It is under node 3. The image cannot be pulled, of course, because it doesn't exist. So let's go and containerize it. To containerize it, I already have, let me find this. So for containerization, we already have a Docker file, and what this Docker file basically do is it's going to install everything my Python service needs So it's going to install the Python dev. Also, I need GCC running on the container because of the WebRTC web, and I also need Ollama. So I need to download it and install it. Then I'm going to copy my requirements text, which are these ones, into the container, into the image, and then I'm going to say, okay, now create a new virtual environment. And one thing which I forgot to do here is, of course, to activate this virtual environment. Just to be safe, before we push anything, I want to test this. So I want to say test one, and then oh, I guess it has removed my Docker. It doesn't matter. I don't really want to install it again right now. I guess it has been removed by Kubespray. Thank you, Kubespray. Let's go on and create a GitLab CI file. And I already have a bunch of these around. So if I come here, gateway, I guess has it. Let me go here and just steal this one. And then everything should be there except that, yep, it's already there. It needs a tag. It should be fine. So let me just push this. Yeah, these are the two files that I'm not pushing because they're like too big and I don't want to put them into the source control. But let's say that CI/CD edit. Then if I come here to Tiba and then go to Tiba again, and then create a release. That would be this one, create a tag and create a release. So I have to see the pipeline start running. Yep, now it is running. So let's check it out and see if it fails. Okay, so now it is published. One thing that I did behind the scenes was that I was realized, well, okay, I have a container and it only is running one Python application in it. Why am I creating a virtual environment? So I just got rid of the virtual environment, was not needed. Yeah, so it creates the my protobuf server, my JavaScript server is published. Now let's go back to Kubernetes and remove this and see if it will find it. So everything here should be fine. So it should not tell us 404. It should fail still. Since it's taking some time, this means that it is a good sign that it is pulled the image. But still, it should fail. If I say inactivate and then I say Python server 5 should run without problem. I guess that maybe worse also. Yeah, okay, now so it's actually it is failed. Just didn't see the thing. Yeah, so this voice doesn't exist. Let's add it now. So it is only this one, I guess. Yep. So it's under here. Let's go on and add it. So here, basically, if it runs, it has to say it is waiting for the wake up. Yeah. So that's what it looks like when it runs. Right now, it's also failed locally. That's also true because I changed something. Let's also fix the code. I'm gonna fix the code quickly. What happened is that in the morning, I mean at 2 a.m. In here, I changed this Tiba to Tiba service, and that's why now it is complaining. So it should be basically here. So yeah, now it's fine. I hope that it is nowhere else. Let me go to the Tiba service. let's check if there is any where we are having Tiba servicer. Yep, we have it here as well. I don't know if this Tiba servicer. Yeah, that should be it. Don't really do anything else. Let's fix this one. I'm gonna fix this and then I'm gonna run it again. We are going to check the volume together. Okay, yeah. So after it runs, it kind of should look like this. Like server started on 14. Yeah, but right now it also doesn't work. I cannot test it because I have a gateway which converts MQTT to gRPC and vice versa. And because of the changes I did in the morning to the gRPC server, that one will not really work. So or maybe it does. I have to check. But it doesn't matter. Right now, let's go on and get the container to this state because the container is still getting an error. Let me come here to the chart. Yep. So what we need to do here is to add a volume. So the volume that I want to add, I'm just gonna call it hyper. And I'm gonna use a post path. I'm not gonna create a PVC with a persistent volume and so on. I should be able to yeah, read the host path from here. This is not let me actually take it out from there. Tiba voices. I'm just going to put this somewhere here. Call it hyper and voices. So we need the US female one. So I'm going to say, okay, because the other one is already there. Actually, the voices folder is already there. I'm gonna say, okay, get home partnersary hyper, go to voices, and US female is the one that I need, and type directory. Then I need to come to my container and say volume mount, name is I don't load it into app Piper. I have to load it into app. Let's find it out again. Under app, src voices and US female. Let's see. And add it, and this. Okay, I think also I can make this read only, but I will do that later. Okay, I fixed some stuff in the chart. So basically inside the chart, I had the volume in the wrong place. Now everything is kind of fine. But apparently the Nvidia driver, like the GPU, is not recognized inside the pod because before it runs, I actually managed to do Nvidia SMI here, and the command is not found. So we have to go on and fix this issue as well, so we can actually also get this running. This is kind of the only thing that we have to do beside the old llama also. Then that would be it. This is a long video. Okay, eventually I think we have this running. One thing that I changed, my image is right now too big, but that's the way it is. I really don't know why I have this, but I just changed the base image. So the base image right now is an Nvidia CUDA image, which matches my CUDA version on the host, and I also installed Python in there, and then I will just do everything that I was doing as before. I don't have old llama here because I'm using the library, it's not needed. But the image is 5 gigabytes. Doesn't matter right now, I guess. uh, and it seems that it wants to run. The only thing that is needed eventually is the gRPC server has to come up and says the server is listening on this part. So let's see if that will happen eventually after killing it, not killing it, just playing around with it a lot. And I realized since I am a Python noob, apparently you need this unbuffered to have actually everything logged in here. So this is this is actually the print that's why without that minus u it was not putting it here. So the service is running. The old llama is not really running because we don't have the models copied here. And if I actually now also come here and do this, I will have my graphic card here up and running, exactly the same graphic card. And yeah, so if I also go to src voices and the US female, you see that it is also loaded here. This is actually coming from my host. Yeah, but that's it. And I would continue, maybe create a new video to actually test it out when I have the gateway running. Because right now the gateway is not running, it doesn't make any sense to test this. And we just wanted to deploy and see how everything works. This was a long video and editing it is going to be fun. Well, actually, when you see this part of the video, it's already edited. I don't know how long will it be, but that's weird now that I'm thinking about it, because the time that I'm saying this is at the end of the video. It's probably at the minute 50 or so. Yeah, I guess so. And yeah, so we wanted to deploy this service in Minikube, but then we saw, okay, maybe we can try to have it inside an actual Kubernetes cluster, which I'm running on my home cluster, and add this machine, like my home machine, like my GPU machine, into this cluster. And we also learned how can we tweak Kubespray to have pop-ons introduced, and also how to run the GPU, how to like introduce the GPU to this node, and then use the container toolkit for Nvidia, and also the Nvidia plugin inside the cluster. We checked how to create a helm chart, which was a really simple helm chart, but yeah, just a review. Also, we checked how to do Flux again, which was also a pretty simple one. We had an existing Flux setup, and then we just introduced a new app to it. So now we have this app called Tiba LLM. And as soon as I have everything running all together, I'm probably gonna create a video when I'm running all of this together and show you the results. Yeah, this was fun, and I hope I have a list there, so it's gonna be done soon. Yeah, but with all that being said, this was fun. Have fun coding, and until next time, cheers.